this lesson, we will be multiplying monomials by monomials. So let's recall just what monomials are. And taking a look at this first term, this is a monomial. It's a number multiplied by a variable to a positive exponent. So remember, monomials, we have the prefix mono in there, which represents the number 1. And so it's a one-term value that can either be a number, like 3. It could be a negative number, like -2. It could even be a fraction, like 1/2. Or it could just be a variable like x, or it could be a variable multiplied by another variable, or even a number multiplied by a variable raised to a power. The trick is, though, that the power must be positive. So that means that we cannot divide by a variable that, or just any kind of variable. And so when we are multiplying monomials, we're using a property. And so the property is the commutative property. So the commutative property allows us to move terms. So it's the commutative property of multiplication, because there's two of them, of addition and of multiplication. And so we're using the commutative property of multiplication by taking the coefficients 3 and 8, bringing them together. And so I also can bring the x's together as well. So the common mistake I see people end up making is they end up not combining all the x's, or not combining all the numbers that are in front of the variables called coefficients. So it doesn't matter whether the 3 was in front of an x or an r or a t. You can bring all the numbers next to each other because everything's being multiplied. See, again, I just rewrote this in a different order using that commutative property. And the word commutative has that word commute in it. And commute means to move, and that's what we did here. So once I've moved those numbers next to each other, I go ahead and multiply. See, 3 times 8 makes 24. I count up how many x's I have, and again, you're just adding. And the neat thing about this monomial is that we don't have any negative exponents. So you're not going to end up subtracting these exponents. You're always going to end up adding them. And so we have 24x to the 7th as our answer for the first problem. Well, let's take a look at a few other examples, see if we can get anything different than what we've seen in this first problem. Here we have just more variables. See, these are all monomials. See, we have a -2. It doesn't matter whether the coefficient's negative. We just can't have negative exponents. We're not dividing by any variables, so it's okay. So again, we're using that commutative property, and we can rewrite this. Everything's being multiplied here, so we could just rewrite it in a different order. See, I could write -2 times 6. Same thing as 6 times -2. So the commutative property allows us to move the terms in any direction we want. We can put them anywhere. It doesn't really matter. So I choose to put them next to each other, the variables that have the same base, so I can combine them together, and the coefficients, and here in this case the t's. So t to the 3rd and just a t. Now if we see just a t, remember, it's just to the 1st power. So now I could go ahead and multiply out those coefficients. I get -12. Count up the number of r's. So I have 2 r's and 3 r's. Do the same with the t's. You get 3 t's and 1 t. So we go ahead and do that work. We're left with a -12 r to the 5th power and a t to the 4th power. There is our answer. Well, here's another example of what we've got. We've got we just have more terms. We have 3 monomials in this case. See, they're separated by these parentheses showing that we're multiplying these monomials together. So all you're going to do is just take the coefficients. And it doesn't matter what they're in front of. They're all being multiplied. So the commutative property allows us to move those terms next to each other. Make sure you bring the signs with them. Be very careful on those signs. Otherwise, you might make a sign error and have the wrong answer. So let's take a look at the next term. We've got some a's. So here we have an a to the 1st power, so 1. We've got 2 a's here, so plus 2. We've got 4 a's here, so plus 4. And then we take a look at the last variable we have, and that is the c. So we have c to the 2nd. Here we have is just a c, so it's to the 1st power, so plus 1. Here we have 3 of them, so plus 3. And then you're just multiplying all those numbers together. So here we have -3 and 2 makes -6. Negative 6 times by this negative 6 that I just brought down makes a positive 36. Then I count up the number of a's I have. I got 1, 2 makes 3, and 4 makes 7 altogether. So a to the 7th. And then count up the c's. 2 and 1 make 3, plus 3 makes 6. So there it is. 36, a to the 7th, c to the 6th is our answer. Well, problems could maybe look a little bit different. Sometimes not everything has a coefficient out in front of it. So let's take a look at this next one. So here we have a 7, and if we don't see a coefficient, it's just 1. But 1 times a number, 1 times 7, isn't going to change anything. So I don't have to worry about that 1 there. But I do have this 2, so let's go ahead and bring those next to each other. And let's count up the x's. So here I have 2 x's, so x to the 2nd. And since we're just adding them, let's just rewrite this as an addition problem here with the exponents. So we have 2 x's, 1x, so I put the 1 here, 3 x's, so I put the 3. Now let's count up the y's. No y's here, but we do have 5 y's here, and we have 2 y's at the end of the problem. Then we go ahead and multiply out those coefficients. So another common mistake is, since we are so used to adding exponents, sometimes people add these two numbers and get 9. But look, we're not adding. We have a times sign right here. That's what the dot represents. You don't see any addition signs in these problems. So you're multiplying those coefficients. So we get 14. Again, go back to the reason why we add. Why we add all these exponents up is because these x's, these exponents, represent repeated multiplication. Let's just go over that real quick. X to the 2nd, that's x times x. X to the 1st, that's just an x. X to the 3rd represents 3 x's, all being multiplied together. And so when you count them up, you got 2 here, so there's the 2. You got 1, that's 3 altogether, and 3 more. See, you count them up, you've got 6 x's. So that's why we add the exponents, because the exponents just represent repeated multiplication. Well, let's take a look at the y's. We got 5 y's and 2 y's make 7 y's altogether. And there's our answer. Well, here's just another example of a problem that we've seen before. We've got some coefficients. Let's bring them together. Coefficient's just 1 on this one, so we don't have to worry about that. So we just have the 12, the 2. Now let's count up our m's. Here we have 1m. Here we have 2 m's. Here we have 1m. And then let's count up the n's. We have 5 n's. We have 1 n. And we have 1 n here. And then we just add up those exponents. Multiply the coefficients. 12 and 2 make 24. You count up the m's, you got 1 and 2 make 3, plus 1 makes 4. So m to the 4th power. Count up the n's. We got 5 n's, 1 makes 6, and 1 make 7. So there it is, 24m to the 4th, n to the 7th. Let's take a look at this last one. Here we just have more variables. Here we have 3 variables we have to deal with. But it's all done the same. You know, you're just using that commutative property. We're taking a look at the coefficients that are just underlined there. Negative 4 times by a positive 3. Then we take a look at the a's. So let's write the base a and count up the exponents. Here we have 1, here we have 2, and here we have 2. So let's write down those exponents. 1, 2, and 2. So we're just counting up what the exponents are on the a's. Now let's go to the b's. B's. Okay, so we have none here, but 1 here, and 3 here. So we do 1 plus 3. Now let's count up the c's. C's, okay, we got 2. We've got 1. Don't see an exponent, so it's 1. And no c's here, so that's it. Just 2 and 1. Well, we go ahead and multiply out those coefficients. We get negative 12. Count up the exponents on the a's. We got 1 and 2 make 3. Plus 2 makes 5. Count up those on the b's. We got 1 and 3 make 4. And then the c's, well, there's 3 c's altogether. So there's our answer. So the next part of today's lesson is going to be multiplying a monomial by a polynomial. So we'll see that in part 2.